Okay, the next problem is another parabola, in this case satisfying the x-intercepts, -1 and 4. And you can actually double check this because obviously, the point -1, 0 has to be a point and 4, 0 has to be a point. So you can check these by plugging them in real quick. Alright, so when you plug in -1 for x here, you do get 4 minus 4 is 0. So they do work, in which case there's solutions to the equation, so you can put them here as well. There's solutions to the equation when this parabola is equal to 0. Plug in 0 for y, and you get these 2 points. Alright, next problem is an absolute value. We're asking basically when this absolute value equals 3, so there are 2 solutions, and we can find them by taking what's inside of the absolute value, setting it equal to 3, and taking what's inside of the absolute value and set it equal to -3, and solving. So when I add 9, I get 4x equals 12, divided by, you get x equals 3. And in this one, when I add 9, I get 6, divided by 4, that's 3 halves. So I get 3 halves and 3. Next problem, I'm going to add 5 to both sides, and then I'm going to square both sides, and that gives me 2x minus 1 equals 25. I'm going to add 1 to both sides, 2x equals 26, so x equals 13. I usually check these, especially when there's square roots and squaring involved, because you can get an extraneous solution, so it helps to double check. Alright, we're going to do this product real quick. So 5 times 5 gives you 5 squared. In the middle, you're going to get 15i plus 15i plus 9i squared, which then we can simplify because I squared is -1. So this is -9 with 25 gives us 16 plus 30i. And that way it's in standard form a plus bi. So I'd write 16 plus 30i. Alright, this problem, the sum of 2 pure imaginary numbers is always a pure imaginary number. Not necessarily, right? We could add I plus -i and get 0, which is a real number. Okay, the next one, the sum of 2 complex numbers is sometimes a real number. Sure, if you have, I don't know, 3i plus -3i, when you add those, once again you get 0, and that's a real number. So yeah, that's true. Every complex number is a pure imaginary number. No, sometimes complex numbers have a real part, like 3 plus 4i, so it's got a real and an imaginary part. And the last one, every real number is a complex number. That's true, right? Because complex numbers, if you remember your hierarchy of numbers that you learned about, you have the imaginary and then you have the real. So like this is like 3 plus 4i. Imaginaries are just like the 4i part, and the real part would be like the 3. So there's some real numbers, imaginary, and complex numbers are actually all numbers. So obviously that's true. Next problem, we're going to distribute. So we have -9i times 4, which gives us positive 36i, and then -9i times -6i, which gives us positive 54i squared. Now I squared is really a -1, so that's going to be -54 plus 36i if I write it in standard form, a plus bi. The next problem, I'm going to do the same thing where I simplify this, so it's -1 times 4. Square root of -1 is I, square root of 4 is 2, so this is really 2i, times 25, same thing, it's going to be 5i. Do the same thing, so that's 10i squared, which I squared is -1, so it's really -10. If I subtract 2 complex numbers, I have 1 minus 13, which is -12, and I have 10i minus a -4i, which is really plus 14i. And that way it's in standard form, a plus bi. Alright, to do this one, what I'm going to do is actually almost like we did with rationalizing the denominator. I'm going to multiply the top and the bottom of this fraction by what's called the complex conjugate, because that gives me a whole number in the bottom. So I'm going to FOIL the top. That gives me 12 plus 9i minus 20i minus 15i squared. And then the bottom, I'm going to get 16 minus 9i squared. So this simplifies to -11i. The 15i squared goes to -1, so that's going to be a positive 15. 9i squared goes to negative 1, so that's going to be a positive 9. So that's 25 on the bottom. And 15 plus 12 gives me 27. So there's my complex number. I'm going to write it like this though, 27 over 25 plus negative 11i over 25, because then it's an a plus bi form, where a is 27 over 5 and b is negative 11 over 25. All right, subtracting the two complex numbers, I have the real part's 3/8 minus 5/6, so 3/8 minus 5/6. Need a common denominator, so whenever they both go into 24, multiply top and bottom this by 4, so it'll be 20 over 24. Top and bottom this one by 3, so it'll be 9 over 24. There'll be negative 11 over 24 for the real part. Plus, I need the imaginary part now. I'd have 1/7 I minus 7/2 I. So I need a common denominator. 14, multiply top and bottom this one by 7, so 49 over 14. Top and bottom this one by 2. So it'd be negative 47 over 14i. And now it's in standard form, a plus bi. Multiply these out, negative 8 times 4, negative 32, negative 8 times negative 4i will be positive 32i. Negative 5 times 4i is a negative 20i. And then I have negative 5i times negative 4i, which gives me positive 20i squared. These add together as 12i. This is negative 1, so negative 20 and negative 32 make negative 52. And there's my complex number in a plus bi form, where a is negative 52 and b is 12. Okay, we haven't done one of these yet, obviously, and we're going to do these throughout the year, but it's asking when is this less than 0. So what I'm going to do actually is find the zeros of this. So I'll try to factor it if I can, so I can find the zeros quickly for this polynomial. 6 and 8, so let's do plus 8 and minus 6. And so the zeros are at negative 8 and 6. So what I can do now with those, negative 8 and 6, is I can put those here, negative 8 and 6, on a number line. And I can test the left side of that. So if I stick in negative 9 here, negative 9 is 81, plus negative 18 minus 48, I can tell if that's negative or positive in this region. And so that is positive. Okay? Do the same thing, let's stick in 0, you get negative 48, so you see that's negative. And then do the same thing when you stick in 7, and you're going to see that it goes back to positive. So basically, we know what this parabola looks like. It opens up and it goes through negative 8 and positive 6. So it goes like that. So we want to know when this thing's negative. Well, that's in this range. So in between here, from negative 8 to 6. So we would say from negative 8 to 6. And we don't want to include either of those endpoints because it's equal to 0 there, and we just want less than 0. So we just want the answer from here to here, or from here to here. Same thing here. I'm not going to graph this. I'm going to make a number line and put the key points on here. The key points are 0, so negative 2, and also where it's undefined, which would be 6. And then I'm going to test each of these intervals. So I'm going to test like negative 3. If I plug in negative 3, I get a negative in the numerator, and I get a negative in the bottom, so that'd be positive. I'll try 0. If I stick in 0, I get a positive in the top and a negative in the bottom, so that'd be negative. And then I'll test a number bigger than 6, like 7. That gives me a positive in the top, positive in the bottom, so that'd be positive. So when is this thing less than 0? Once again, from 2 to 6, negative 2 to 6. Not including those points because it's equal to 0 at those points. Okay, next one, if I'm solving this, I can take what's inside and set it greater than 0, and then take what's inside and switch the sense of the inequality and change the sign on the number to the right. But that's 0, so negative 0 is still 0. So I just need to solve these, which this is x is greater than negative 6, and x is less than negative 6, which is interesting. That's what I enter in here. But that's all numbers except for negative 6, which makes sense because we know that absolute values look like this. And we've added 6 to x, so we've shifted this over 6 to the left. So it looks like this over here, where all numbers it's greater than 0, except for at negative 6 itself, which it's equal to 0 there. Here's my answers. This is a parabola once again. They give us the key points at 1 and at 5. So test below 1, like 0. If you test 0, you get a negative and a negative, which makes a positive. Test in between there, like 2, you get a negative and a positive, which makes a negative. And test above that, once again, you get a positive. So when is this thing less than 0? You'd say from 1 to 5 in interval notation. Last one, take what's inside, x minus 9, and set it less than 9, and then take what's inside, x minus 9, set it greater than. So switch the sense of the inequality and the sign on either side. Do this side, it's easier. Now solve this. So add 9 to both sides, and you get x is less than 18. And then on this one, add 9 to both sides, and you get x is greater than 0. So basically, 0 is less than x is less than 18 is our answer. It wants it in, the answer on interval notation. So we can do 0 to 18, not including either one of those, because at those points, it's actually equal to 9. All right, I hope this helps.